Good? All right. Okay, cool. So welcome to COP340, Building Reliable Operations featuring Fannie Mae. My name is Bobby Hallahan, and I'm a solution architect here at AWS. So what are we going to talk about today? What we're going to focus on mostly is what is reliable operations, like what we mean by that, and at least why I think it's important, and hopefully by the time you all leave the room today, you'll think it's important too. But to cover that, we're going to talk a little bit about our AWS Cloud Operations philosophy. So we'll talk about how we do operations here at AWS. From there, we'll go into a little bit of tooling, right? So this is a 300 level session, so I'm assuming that you're going to know most of this stuff. But we're still going to cover a little bit of it and hit some advanced topics. We'll pepper in a demo there that I think you all enjoy. And then from there, we'll cover Fannie Mae's story, right? Because it's easy to, talk the talk, right? It's easier said than done. You may have heard that before, right? So if we come up and say, hey, you got to do, all these different types of mechanisms, let's bring a customer who's actually done it, and they're going to tell you about some of the pitfalls they made, some of the value they got out of it, and some of the things they may have tweaked to make it, work for their organization. So what we want to be able to, what I want you to walk away with today is not just understanding how AWS does ops, but then how you could actually take that and apply it to your own organization as well. And then just as we wrap up, and just so you also leave with something you can do today, right? Because redoing your entire operations model, that can, that's not a one-day thing, right? That's not something I can go home and we're doing that next week, right? It's tough to do. It can take time. So we want to make sure you're getting something immediately valuable, and we're going to cover 5 advanced reliability cheat codes that you can actually start doing probably tomorrow, next week, so you're getting immediate value from this session. Okay, so without further ado, this might be a leading question, but when we think of what is one of the most important features of an application, right? Some say security, and that is important. But since we're in an operations-focused session, the name of the title of the session is, focused on reliability. I would say reliability is an important feature of an application, if not one of the most important features of an application. Also, depending on what you do, right? If some applications they're zero fail missions, right? They need to run. So with that said, what do we think of when we think of reliability, right? Think about that. You're normally thinking maybe HA architectures, DR, multi-region, cell-based architectures. That's what I think of when I think of reliability, right? It's all in, it's in well architected too. That's what you normally think of. However, what do we think of when we think of operations, right? We think of, operational excellence, operating well. However, normally, at least when I speak to customers, and I would say probably at face value, right, operations almost seems disconnected from that reliability perspective, right? Where it's normally, hey, we're thinking hardware and software and resilience. However, if we take a look at the numbers here, why systems actually fail, if you take a look at it, it's really 42% of system failures, and we're talking about degradation of service, is caused by something that happened in operations. So when we think of reliability, and my contention is that instead of perceiving just all 3 of these, right, and what we're going to talk about today, so just full disclaimer, we're not going to get into cell-based architectures. We're not going to necessarily talk about multi-region type stuff. What we're going to focus on is how to build reliable operations. And while these can be separate, what we'll focus on is the operations piece. So that's what we're in for today. So let's jump right in. And specifically, let's talk about how AWS does ops, right? So if everyone's seen culture of innovation talks, where we talk about, well, actually, we'll get right into it, but some of this may seem familiar to you. But if not, hopefully you'll learn some stuff. But I always like starting off with a quote, right? Which is, good intentions don't work, mechanisms do. Right? A lot of times I like to think it's hey, I'm a nice person, I try to help people out, but if there's no mechanism in there to do it, if you get busy, nothing happens. Or it's hey, we want the application to run at, to be up all the time, but just feeling about it, trying, having a good intention doesn't actually force it. You need mechanisms to force things like innovation, force things like reliability. So let's cover a couple of mechanisms we have at AWS. So the first is our 2-pizza team, right? And the idea behind a 2-pizza team is, your team size shouldn't be as big that you wouldn't be able to feed with 2 pizzas for lunch. Now, what does that get you, right? So generally speaking, right, you don't want very large teams, but you don't want too small teams. And really what it gives you is a team that's owner-operator mindset, right? So they're the first contact for alarms. They manage their own operational environments. They automate as much as possible, right? So you're also driving that decision tier, right? That ownership down to a low level, right? So you have baked in stakes and ownership within those teams. So that's something we've embraced here at AWS. And I know that model may not work for everybody, but it's we feel that it's beneficial and has a lot of benefits. Now, what's the next big mechanism we have? Another thing you may have heard of is a COE, or a correction of error. And what this is essentially a blameless autopsy to learn from our mistakes, right? So who, what, why, with data to back it up. We have action items to ensure that exact specific cause of that error doesn't happen again, right? So like what happened, it's okay if a failure happened, but we need to make sure we have a mechanism put in place to make sure it doesn't happen again. Now, the big key to having a successful COE is being transparent about what went wrong so we can learn about it, right? So COEs need to be transparent. The big thing, and if you are to implement this, I would say the single biggest thing you need to make sure of is a COE is not to blame people. It's not to punish people. They need to be based, it's a learning mechanism, right? Because the second somebody thinks that, this is a mechanism to show blame, or it's a mechanism to, somehow punish somebody for making a mistake, that fact of you need transparency just is totally out the window, right? Because if I think my job's on the line because something went wrong and I need to write a COE, people may not be as forthcoming with what the real problem was, right? So my advice is you should look to adopt some sort of COE mechanism. And if you do that, the thing of most paramount importance is that it's not to blame and it's not to punish people. It's a learning exercise to make sure you can prevent specific errors from happening again. Now, a couple other mechanisms that we find important. First one is SLOs, or service level objectives. So if you may ask, all right, what is an SLO, right? So these are measurable service quality targets derived from user perspective metrics that drive continuous improvement in IT service delivery experience and readability. I know that's kind of a mouthful, so let's kind of look in a specific example what we mean by an SLO. And in this case, we'll take a look at latency, right? We have a latency SLO for maybe a payment processing platform on like maybe an e-commerce site, right? And we would say we want our goal to have 99% of payments should process within a certain time. So that would be our P99. We would want a certain attainment of that latency, so attainment of a goal, and then we would monitor that using some sort of APM tool, right? So you have attainment of the goal as well as if you have requests that fall outside of that, right? That would then factor in something like a burn rate. So then you can create burn rates on your SLOs, knowing that you would be close to breaching something, meaning that you can then take action before potentially you even breach an SLO based on burn rates. I would say the big takeaway here is probably looking at how you're instrumenting your workloads, that the telemetry that you're actually sending out or stitching together after the fact gives you something that gives a real reliable understanding of the health of that application. So you can then derive what the SLO is, right? And if you don't, then that's maybe something you would want to start thinking about. Now, other neat ones, and this is actually something we're going to demo in a little bit, which is leveraging automations to maintain safety while reducing MTTR, mean time to resolve. So what this gives us is doing some automatic type incident remediation. So instead of alarm fires, right? Instead of having somebody look at it, somebody gets paged, maybe we try some automatic remediation. Right? Maybe we'll try to run some runbooks, and then if that doesn't work, then we can start maybe involve a human. Or even better, when we involve a human, we want to give them context, right? So maybe we'll do some enrichment on that data and then send it down. So then that alarm is actually actionable to an operator. Instead of getting paged at 2 a.m., it's like, oh, some alarm. It's like, oh, 400s? Like 400s for what? For what service? Where'd it go? Where's the dashboard, right? Having all that information can be helpful. So we'll demo a little bit of that today. And then, of course, proactively preparing for incidents. These could be things like tabletop type exercises, understanding like what would happen if this broke, what would happen if, or even actually running game days too. Or even getting right into it and injecting actual faults, right? Using something like fault injection. I would say, maybe tabletop a couple things before you actually start like actively throwing faults in your systems. But the idea of being able to proactively prepare and understand the failure modes of your application, and more so from like that operations perspective, knowing that's like, okay, who gets paged? What's that escalation mechanism? Where are those runbooks? What's the dashboard operators? Like how all that stitches together and happens. It's not magic, right? It's hard work and it's practice. And I would much rather say you would want to practice when nothing's wrong than at 2 a.m. or maybe in the middle of a very large event where, potentially millions of dollars per minute are on the line, right? Where you're looking at reputational or financial loss. Now, those are a couple mechanisms, but what I want to focus on now is a quick overview of, just how we cover cloud operations. So when we think of like the building blocks of cloud operations, we have CloudWatch, Systems Manager, Config, and CloudTrail. What we're going to focus a lot on today is going to be a little bit of Config, a little bit of Systems Manager, a lot of Systems Manager actually, because it actually lets us do a lot of really neat stuff. So let's jump in. So when how do we put those building blocks together? We would have observe, right? So this is like understand what happened. You can use things like config for your configuration items, understand compliance there. CloudTrail is a good indication of that, as well as CloudWatch, right? And then be able to decide, right? So like when things happen, how do we decide? What's that decision logic look like? How do we route things like event bridge or step functions or systems manager? And then actually acting would be, taking response and action to something, right? So for example, I would argue, or I would say that systems manager is a really great way to do that. So now with that, let's talk a little bit about Systems Manager, right? Because there's a lot to it. Systems Manager is a really powerful service. There's a lot of capabilities. But what I'm going to do is I'm going to try to give you like the very high level so you'll just understand Systems Manager essentially without having to know every single feature of it. And what it has is essentially you have automations, right? So these are almost kind of like step functions, right? There's actions you can take in response to events. You tie them up with Event Bridge. And they're step-driven approaches that you can do to execute APIs, run scripts, all this neat stuff outside of the context of an instance. And then you have the agent, right? So this is the actual SSM agent that lives on the instance that allows for things like remote management, patch management, session management, and then, of course, node management, right? So the node management could be if I need to do things across many instances, right? That's where I can use automation. But at its core, Systems Manager is agents and automations, right? Agents allow for run command. Run command helps perform and do a lot of things with SSM. Now, I speak a little bit about automations, right? So it lets us execute critical tasks, operate operational tasks, or automate operational tasks, that is, streamline some things that are complex, and then gives you more visibility and control. And this is something that we'll be able to show here in very quickly. So we launched a automation runbook builder just about this time last year. There's been quite a few improvements to it, which we're going to show off today. But what the Runbook builder lets you do is it's a low-code visual designer that empowers users. It gives you visualization. You can author effectively and securely. So it's really neat. So instead of just showing you more of that and telling you about it, let's actually go check it out. All right. Okay. So as we can see, here we are in the SSM console. And we can see right here, like, okay, how do we get to this screen? It's right here on automations. And I can see all the automations that have been running. I can see some are waiting, some have failed, and some are successful. So let's take that scenario, right, where I have an alarm that I'd like to process, right? So I want to add some sort of automation logic to my alarms. So let's go ahead and actually create a new runbook. And from here, what we're going to get is we can see on the left-hand side, we have like flow control states, so branching, looping, sleeping, pauses, approval states. We have things from like scripting, like running a script within the automation itself. So instead of like, let's say, hey, let's run a Lambda function, like trigger a Lambda function to run, I can actually do some scripting within the automation itself without necessarily having to invoke Lambda. And then, of course, resource management. Now, in addition to the flow states, we have AWS APIs. So essentially, almost just about any API you can think of, right, you can use with automations. And I would say this is where it gets really cool, is that automations can be used to execute other automations. So if there's like reusable components that you've built in an automation, you can start nesting those together. So let's say I don't necessarily know where to start. What we can do is we can take a look at some of these samples that are built in. And what we're going to do here right now is let's take a look at this hello world example. And I'll walk us through it right now. So what we can see is it's a branch decision state that goes to an approval state, some sort of delay, an execution loop. So this is a loop state where we want something to try something several times. Well, that thing we're going to try is actually a script. And then we'll have it repeat and then end. So this could service a little bit for that use case, right? There's something that we have an event in response, we're going to try something a few times and end it. But what is something that we might not necessarily want to have on alarm automation? Having a manual approval step, that could slow us down a bit. So maybe we can just, get rid of that. Now, let's say we want to do, maybe our automation works, right? Or it fails. In either case, I'd probably want to know about it. So we can just jump to our AWS APIs and we'll search for SNS. And we can say, we'll go ahead and publish. And we'll call this one, good. And then maybe we'll add a different one and we'll call it bad. And then from here we can see our inputs where we have our message, and then I can have additional options where I would target the actual topic ARN. So then I can have a specific message that comes from the output state of the previous states from our automation. However, let's say our automatic fix just works the first time, right? In this loop state, it would then apply the same fix 2 more times, right? Because it says run 3 times, so it's going to run 3 times. What we can do here is we can actually use a flow control state and add a branch right here at the bottom. And what this branch is going to let us do is, based on the output of our script, we can determine what to do next. So for example, we can go to our inputs and I can say rule 1, and we'll add a condition and we'll say, if the output of our output payload here, right? So this is that script that we're running, what that output payload is, and let's just imagine it can fix some stuff for us, and maybe it can then set an alarm or look at an alarm state as well. If it's equal to something, and we'll say let's just say it's okay, right? We can then say, instead of adding a new step, we'll say just go right to good. And you see that it just broke out of the loop. So that based on a conditional argument, we can break out of the loop. And then for our default action, so let's say if it's not good, or really anything else, we would then want to say, instead of adding a new step, we can just go right to the end and repeat the loop. And then for this, we'll just change our do while, and then our output and config. Next step is bad, and then for bad, we'll go to our config and go to end. So that's what it would look like, right? We have our delay, a choice. We'll try some automatic fix. If it works, break it out, go to good, and that's the end of it. And if it doesn't, after 3 times and it fails, then we could then send a different notification message, right? So the idea, what I want to demonstrate here is just, in a couple minutes, we built that. And then if we want to gut check it and say, okay, how do we actually string this all together? It's pretty straightforward. All we need is a CloudWatch alarm, and then give it an alarm. And as you can see, this alarm state has been changing over time. We just need to create an event bridge rule. And I'll zoom in a little bit so we can see it. But the event bridge rule just targets for my CloudWatch alarm. You can have it trigger for any alarm, right? But you can also have those event bridge rules focus for a specific alarm. And then for my target, I just point it at the automation. I give it an IAM role, and we're off to the races. So if we want to take a look at the whole thing, we can see that's what it looks like in practice. And just to prove that I'm not just showing you, okay, here's something that, looks good on paper. We actually did build it, and we can take a look where it actually succeeds. And if we check it out, we can then go and see each and every specific action that took place, a success or error state, And if those error states do occur, we can then jump into the logs. So when we talk about like an easy way to start building runbooks, it's not just building a runbook, it's also being able to debug it. Because if it breaks, you know exactly what step it broke in. And you have the ability to do step-by-step executions of these as well. So I guess with that said, the very last thing I want to cover here is config. Right? So we talked about Systems Manager. One thing you do want to know about when it comes to config is essentially we'll create resource items when a resource changes or periodically changes. It creates, we have configuration recorders, which creates a rule. Rules evaluate compliance, which is a desired state or an undesired state we'd like to have. And let's say if a non-compliant rule does happen, we can then remediate that. And in that box, you'll see it says Systems Manager. But really what that is, not a trick question, but it's an automation. Every remediation within config is an automation. So I guess think about like what are other things we could do with automations, right? It's not just automating some tasks, but we actually are using this within our own services as well. Okay, so without further ado, we'd like to talk about like how all this is good, right? But like how can a customer do it, right? And who I'd like to invite on the stage is Moise Halani, who's going to walk us through how Fannie Mae has been able to adopt our cloud operating principles and be successful in it. Thank you, Moise.
Thank you, Bobby. Can you guys hear me okay? So good afternoon, everyone. There was some really good information from Bobby on reliability. I am Moise Halani, Vice President of Operations Engineering at Fannie Mae. Some of you may think, who is Fannie Mae? Fannie Mae was chartered by the US Congress in 1938. We promote home ownership and make housing available in US by providing stability and liquidity to the housing market. About 1 in 4 mortgages in the US are owned by Fannie Mae, so we finance 1 in 4 homes in the US. We have more than $4 trillion in assets. Our balance sheet is the largest in the US and 5th largest in the world. So you can kind of imagine the scope and impact of Fannie Mae. When Fannie Mae sneezes, the mortgage industry catches a cold. There's all sorts of lenders across US, some big lenders who have built their applications around Fannie Mae's systems. So you can kind of imagine the importance of reliability, stability, and performance of Fannie Mae systems. And I'm sure you guys also face challenges with your systems when it comes to stability, reliability, performance, and so on and so forth. So today I'm actually going to share 3 strategies that we implemented at Fannie Mae, and I'm going to share some of the achievements in terms of performance indicators that we landed. So about 6 years back when we started our cloud journey, we took a value-driven approach, and there were certain outcomes that we were looking for. We wanted to prevent financial impacts. We wanted a higher regulatory compliance, faster time to market, a higher customer satisfaction. We wanted to minimize operational disruptions, increase productivity, and so on and so forth. And now, when you kind of fast forward 6 years, what I can tell you is that we have some best-in-class performance indicators, and it's not like our KPIs were not good. They were pretty good, but we went from good to great. And here are some of the KPIs. So we reduced our critical incidents by about 71%. So you can imagine, if, let's say over a period of time, if we had 10 critical incidents a few years back, today we only have 3. Our change failure rate is down by 75%. And I want you to kind of take a step back and imagine us pumping in about 10,000 changes in a particular period of time across Fannie Mae systems. And out of the 10,000, There's only 2 or 3 that actually cause business impacts, right? So you can kind of do the math on that. And then in terms of mean time to recover, we're down by about 80%. What that means is before our cloud journey, if it took us 2.5 hours to resolve an incident, now it only takes us 30 minutes. And then the last thing I would share in terms of KPIs is that when you think about AWS platform-caused incidents, it's about 3 per year, right? So, some really good numbers is what I can share with you that we've achieved. Now, how did we achieve this, right? So, I'm going to talk a little bit about that here. So the 3 strategies that I spoke about, the first one is integrated observability and incident management. So we have our homegrown tool called Sentinus, which provides us with real-time alerting and monitoring, event correlation, and so on and so forth. Now, we obviously have CloudWatch, EventBridge, AWS Personal Health Dashboard, OpenTelemetry, and so on, writing to Splunk, and then from Splunk we're making API calls to write into our Sentinus tool, like I mentioned earlier. And then we have other tools such as Dynatrace for app monitoring, and then we have some synthetic transaction monitoring tool called Catchpoint, and some other tools. They all kind of bring the data into Sentinus. And then, of course, we use Xmatters for paging our support teams and so on and so forth. Now, what this has done is this provides us with end-to-end transaction tracking as well as visibility across the board, right? So we can kind of slice and dice the data in terms of VPCs, accounts, and so on and so forth. So even before AWS reaches out to us, notifying us about an incident, we already know what the incident is, and most of the times we know the cause of the incident as well. Now, the other thing I'd like to share is we also built runbooks using GenAI, and then we enhance them using automation. These are runbooks for standard operating procedures like reaching out to different support teams or reaching out to AWS TAMs and so on and so forth. We also implemented monitoring as code. So this is where we have consistent alerting and monitoring that we've applied across all of our applications. And then last but not the least, we've implemented chaos engineering as well across many of our applications using AWS Fault Injection Simulator and a few other tools. What chaos engineering helps us do is, we learn from those exercises, and we're able to kind of take those learnings and apply them to our systems to kind of make them more reliable. Now, in terms of outcome, what did we achieve? Much faster detection and recovery, quicker incident resolution, improved operational resilience, and then, of course, self-reliance of the teams. So, this is something that kind of comes into play before the incident. Now, let's talk about another strategy when it comes to what we do during an incident. So, as the AWS CTO Werner Vogel says all the time, everything fails all the time. And that's true, because things do fail. I think what is important is how do your systems recover from those failures, right? What type of tolerance you built in, what type of defensive mechanisms you built into your applications, and so on and so forth. How many of you are using automation to fail over from one region to another? So there's a few hands. So some of you may remember the December 2021 event where there was an Amazon outage and there was an issue with Route 53 control plane. We were impacted by that outage as well. And we took the lessons from that outage and we built automation patterns where we took away the dependency on the Route 53 control plane. We also made those automations independent of the CI/CD pipeline. Because again, if your pipeline is sitting, let's say in East 1, and if East 1 has a failure, right, you don't want to be dependent on the pipeline to fail over all the other assets. And of course, we built all of this using AWS native services like CloudWatch, step functions, Lambda, and so on and so forth. The other thing what we do is we do have our teams exercise these failovers on a periodic basis, which obviously builds muscle memory for them. And even the October 20th event that we just had, we were able to fail over majority of our critical applications using these automation patterns. So, a really good outcome. And just at a high level in terms of outcomes, as you can imagine, we have faster recovery coming out of this, autonomous operations, it has enhanced our business continuity. And the last thing is we've empowered our teams, meaning let's say an application onboards a new service from AWS. The teams are independent and they can go in and kind of make updates to those automation patterns so that they can continue to use the failover mechanisms that we built. Now, I know Bobby touched upon correction of errors, right? So a few years back, we had a fairly mature postmortem process. How many of you guys have some type of a postmortem or a root cause analysis? There you go. A lot of hands, right? So we had a pretty good postmortem process, but we wanted to improve upon it, right, and innovate. So we took AWS's correction of errors framework, and we applied some Fannie Mae tweaks to it. Now, it has the normal features that any root cause analysis would have, which is your incident summary, impact, timeline, and so on and so forth. But the main things that really worked for us were the 5 whys, the lessons learned, and the action items. And what we do is every week we have a call with some very critical stakeholders, and we take the critical incident from the previous week. We invite the root cause CI owner, the impacted CI owners, our business stakeholders, our risk stakeholders, and many other partners across Fannie Mae. We invite them to this meeting, and we start out with 5 to 7 minutes of quiet time at the beginning, where folks read the COE document, they're able to take their own notes, and then we open up for questions. Now, what we also do is we ask our junior members to start asking the questions before the senior members, because what we don't want is a VP such as myself starts asking a whole bunch of questions, and then the conversation kind of gets influenced and goes into a particular direction. So that's why we encourage our junior members to, kind of raise their comments and questions and so on and so forth. Now, on top of that, in terms of Fannie Mae tweaks, what we do is we run a monthly forum where we actually talk about the lessons that we've learned from some of these incidents and how we have implemented those patterns across other applications, across the enterprise, which has been fairly instrumental, in us kind of achieving some of the reliability results that you saw earlier. Because, we do take those patterns and we convert those into work streams where other teams are able to kind of implement those action items. So in this monthly forum, again, it's the same set of stakeholders plus many more, and we kind of go over some of the critical incidents over the previous month. Again, we don't go into too much detail, just a high-level summary, but we try to focus on the patterns coming out of those incidents and what we're doing with those patterns and what is the outcome of the work streams and so on. In fact, to a point where we've had business teams come over to us and asked us to train some of their team members because they wanted to implement the COE process within their teams, especially when it comes to business process failures and so on and so forth. Now, what were the outcomes, right, that we achieved as a result of this? Of course, accelerated learning. Like I mentioned, we were able to learn from these incidents and look at the patterns coming out of those. And again, right, that's improved knowledge sharing, data-driven decision making. So, imagine, having a few applications kind of running into similar type of issues. Now we have the data to ensure that we're investing, just with those applications, and it's not any kind of a biased approach. And then blameless accountability. I know Bobby touched on this. We're not looking to blame anyone. We're not looking to punish anyone. It's really about improvement first kind of a mindset. And I'll give you an example. Let's say there is an incident which was caused by a human error. Now, we don't think of that human as being the cause. We try to look at, well, why did that human commit an error, right? So maybe the support engineer was working on 4 different change tickets, or maybe there were 2 or 3 incidents that came in at the same time, right? It could be so many different factors, so we try to get to the root cause of those. So those are kind of the 3 strategies, right? So to wrap it up, we talked about integrated observability and incident management. We talked about how we develop the automation patterns and how we're using them during an actual failover. And then we talked about implementation of the COE process across Fannie Mae. Now, today, I want to leave you all with a challenge, and that challenge is to take one of these strategies and implement that in your organization, maybe starting as early as next Monday. And again, take baby steps. Small steps lead to big outcomes. So thank you for your time. And at this point, I'll invite Steve Rice. Steve is going to talk about, he's basically going to give us some critical nuggets on advanced reliability, and he's also going to present a demo. Thank you.
All right. Thanks, everybody. My name is Steve Rice. I'm General Manager for AWS App Config and Parameter Store, which are 2 tools that are used for reliability and moving faster. I'm going to give you top 5 cheat codes that we've observed at Amazon when you want to increase your reliability. I was talking to somebody who's here from Sony PlayStation. He probably has some different cheat codes, so you might want to find them afterwards, but these are sort of operational cheat codes that you can implement. These are things that ideally you can start implementing tomorrow or maybe Monday when you get back. Some of them, depending on where you are on your reliability journey, might be a little bit longer, but again, these are things that we use, and we use them at scale inside of AWS to make sure that we're delivering high reliability and high availability. So the first thing is talking about the 3 pillars of change. And there's a QR code on all these. You feel free to scan the QR code. But really, there's a phrase I like to say that the enemy of reliability is change. But change is a necessary part of developing software and running a business. So of course you have to make changes, but most of the outages that we see are caused by some sort of a change. It could be a change to an application, infrastructure change, or a configuration-related change. And if you look back in the past 18 months, there's been a lot of kind of famous changes and outages that were caused by configuration updates. So, but you all are probably using some sort of CI/CD tools, and they probably have some change control pieces, but you may not have them enabled. And the 3 core pillars I would say you absolutely have to enable are, 1, make sure that you're changing things gradually. You don't want to turn something on everywhere all at once. You want to turn it on slowly for 1% of your fleet or 1% of your customers, and then 10%, and then 20%. I say at Amazon we always develop very quickly but release very slowly, because if we release something and it only affects 1% of our customers, it's very different than if we release something and instantly it affects all of our customers. There have been some of those incidents, but ideally everything we do starts very small and you control the blast radius of those changes. So releasing slowly over the course of days or weeks is a must-have. Number 2, you always want to have rollbacks that are configured to automatically roll back the change if an alarm goes off. If you're using CloudWatch or Datadog, New Relic, any of these kind of things, they all are going to sound an alarm when something's wrong. If you're in the middle of a change, you should have that alarm actually trigger an automatic rollback. I always say this is like having automatic braking in a car. Today, I would never drive a car if it didn't have some sort of collision detection. You want the same thing in your pipelines to be able to say, hey, something's dangerous ahead. I'm hitting the brakes. I'm rolling everything back. And again, you can respond very quickly if you're only not even out to your first 1% and it gets rolled back. That's a very different type of customer experience than if it's all the way rolled out. It's been out there for 3 days, and then you realize there's a problem. The last thing is a pre-deployment validation test. Most people are probably doing integration tests or contract tests, those kind of things already. In the case of configuration data, you probably want to make sure that you are deploying valid, if it's JSON, for example, valid using JSON schema, valid JSON or valid configuration data. So you want to make sure you have some sort of mechanism there to make sure that what you plan to deploy is what will get deployed. So those are sort of the 3 core pillars we follow at Amazon for any type of configuration update, any type of code deployment. The next cheat code is moving to trunk-based development. We talk to a lot of customers that are building their software, and these are the application developers more than operational teams, but they're building their software using branches. Branches were a great technique. If you want to improve resiliency, I'd highly recommend moving to trunk-based development. It provides a lot of benefits, especially when you want to roll something back. So the idea is you don't have these branches that live out there for a month. Something has to be merged in. Sometimes the merge is successful. Sometimes it's semi-successful, and that rolls out to production and can cause some problems. Using trunk-based development, you're developing everything on the trunk. If you're not ready to release the feature, you use something called feature flags, that's the next slide, to control the release of that feature. But this really gives you a lot of control about how the software is getting deployed out to your customers. Tied to that trunk-based development is this idea of feature flags. Can I ask, are there any groups today using feature flags? Okay, great. Yeah, feature flags are a great tool, not only for application developers to release features, but there's something we call operational flags. Those are must-have in your toolbox. And I'll talk about that in just a second. So typically a feature flag, people think of, I have a new feature, I want to gate access to that feature through a little configuration toggle that says, is feature enabled? If so, let this code execute. If feature is not enabled, then hide it. And so again, your developers can actually develop on the trunk. They can push the code to production, but nobody can access it. And then when they're ready, they flip that feature flag on for 1% of the fleet or 1% of the users, and then 10% and 20% release that gradually. But that decouples the launch of the feature from the deployment of the code, which again allows you to react much faster. If something goes wrong, you can just flip that feature flag back. You don't have to pull the whole deployment back, put something back in your CI/CD pipeline, and depending on what you're building, that could be hours before that thing gets fixed. So again, feature flags are a great technique. Operational flags are these long-lived feature flags that allow you to control things like maybe the number of background tasks that you're going to allow. And during peak time, you might want to actually lower that number because you're at capacity. We didn't invent feature flagging at Amazon, but we use it at scale. And actually this week and last week are huge feature flag weeks for us. This week, every single thing you see that gets announced was hidden behind a feature flag, and no code was pushed. The code is actually pushed to production for all these new features that were announced at the keynote a couple weeks ago, but the feature flags were flipped today. On Black Friday on Amazon.com, they use AppConfig in order to control some of the operations. I think you probably all have bought something on Amazon that says customers that bought this also bought this. And we might say, oh, let's show them 5 things. Well, those 5 things can be an expensive query. So during Black Friday, sometimes that gets down to just showing 3 things, for example, and that really reduces the CPU on that operation. One final thing, I'm going to do a demo on this, is flags can be automated to be turned on and off. Bobby showed you some automation. I'm going to sort of riff on that a little bit. Okay, cheat code number 4, the ORR. This is something super easy to implement, and it makes a huge difference to how you operate. And it's a really simple concept. The idea of an ORR is it's just a checklist. It's a checklist of things that you think are important for the services that you operate. And what we do at Amazon is we do the ORR, Operational Readiness Review, once a year. So we make sure that, hey, is everything all good once a year? We also do it before the release of a major feature. So it happens a couple times a year. But that checklist is managed by the senior developers in our company. And all the things in that checklist are actually ideas that came from some of the COEs that happened before. Were we prepared to scale? What happens when you have a noisy neighbor? Are you prepared to throttle a single customer so that it doesn't take down the whole service? Those kind of things. So we have a checklist of things that we have to do and make sure that we're prepared when we release a new feature and just making sure that our services are healthy. You don't want that checklist to get too big. It can get really onerous, and it shouldn't take months of work for a team to run through the checklist. So you need to have a mechanism to cull that list, the ORR, to make sure it's just the most important things. But again, it's a checklist of best practices, and it makes a huge difference. And that way you can take the knowledge of those very senior engineers that have seen a lot of stuff and put it in the hands of very junior engineers. The last is a culture change, and my guess is if you're here, you probably already feel this is an important thing for your culture, but resiliency is a feature. We say at Amazon, the most important feature that we offer to AWS customers is security. The number 2 feature is availability resiliency. And the number 3 thing is whatever your service does. So really, honestly, the idea that you need to make sure that your service is available has got to be the mindset. You might have some product people on your team that are saying, oh, we can gain 5% more customers if we add this feature or that feature. And those features are important. But even more important is resiliency. And getting back to that car metaphor, would I buy a car that didn't have heating steering wheel? Yeah, I would. Would I buy a car that didn't have CarPlay or something like that? Yeah. Would I buy a car that didn't start reliably? No. That availability and reliability of that car is the most important feature. And you need to make sure that that is understood at the top and that cascades down. That can't be something that is from the ground up necessarily. So, okay. I'm going to do a quick demo here. I'm going to show you AWS App Config and a feature flag. I talked a little bit about feature flags. This is going to be an operational flag. And a common use case that we have is that we want to be able to control the logging verbosity with a feature flag. You might have something sort of suspicious happening on production, and instead of pushing out a change to your code that changes the log level, you want to control that through a feature flag, and you can get that pushed out in seconds. Okay, so let me go here. What I'm showing you here is the console for AWS App Config. Of course, all this is available with infrastructure as code, and there's a Terraform module, there's Cloud Formation as well. But we have a couple different things here. I'm going to choose a feature flag, and I'm going to create what's called a configuration profile. That's a collection of flags that you might want to group together. You can put a single flag in there too. But here I'm going to call this logging verbosity. And I'm going to create a flag within there that is really going to be the thing that we toggle. This is, again, the verbosity value. This is how it's referenced in code. You have your code reaching out, reading that configuration value, and it's doing it on a regular basis. It's every 5 seconds or every minute or whatever makes sense for your use case. We do have the ability in App Config to also set a flag as short-term. You don't want to have a lot of clutter of stale flags in your code. That can be onerous and difficult to debug. So we have that ability. This is an operational flag, and I'm actually not going to set this as short-term flag. And I'm going to enable that. So now my logging will be controlled by this feature flag. All right, so here I'm going to actually add what's an attribute. It's not just going to be a toggle yes, no, should I be debug. I'm actually going to put the log level in here because you may want to have a different log level than you think. So here, again, I'm going to put the value. I'm going to put type string. And here I'm going to say, by default, we're going to just log at the info level. All right, and then with app config, we think of configuration like code. It's just as dangerous as code. So you can make an update, but it's not available until you deploy it. So I'm going to go and review the changes I made. Yes, and it's set to info, which is correct. And I'm going to actually deploy the change to my feature flag. I'm going to update the flag. I'm doing a demo here, so I'm not going to make you watch paint dry. I'm just going to do an instant deployment. But again, the idea is, unless it's really urgent, I'm going to deploy it slowly over the course of minutes or hours. Okay, so I've deployed the change. I'm logging now at the info level. My code is reading this feature flag. I'm going to go over to CloudWatch. and set up an alarm here. And this alarm is going to look for suspicious activity. And in particular, just as a sample idea here, you might want to monitor how often things like IAM roles are listed. And in your workflows, that might be something that happens regular times during the day. Of course, it's just part of your operations. How many times are you listing all the IAM roles? But if one day you get a spike in those things, that seems kind of suspicious. What's going on? What process is triggering that? And you're going to want to have additional logging to understand what's really going on here. So this is just using sort of anomaly detection, where it's just listing, it's tracking how many times you're listing IAM roles. The alarm, once it's detected, is going to kick off some automation. The automation it's going to do is it's going to toggle that feature flag to go from info to debug. So going to click on actions here. Bobby already showed you the visual automation builder. It's super cool. I chose a simpler route here just for demo purposes of just calling a Lambda, and that Lambda in turn is going to call appconfig and toggle that feature flag. It's also going to do a message because you're going to want to know if this kind of thing happened. So I have set all of this up. The alarm is configured to monitor, look for anomalies, and then do this automation of flipping the feature flag. In almost like a cooking show here, I'm going to jump over and, wow, it alarmed. You see those red peaks where something went wrong. So this is where suspicious activity was detected. It might be something normal. We don't know, but I want to start changing my logging level. And you can see that green bar, and there's a couple reds. Those reds will trigger that Lambda. So I'm going to jump back over here to appconfig, and I'm going to check that flag. And indeed, when I look at the attributes of the flag, it has been flipped over to debug. Okay, so that's a way that you can react without a human being in the mix. The automation can react much faster than a human being can, and that's a core secret to making sure that your resilience is very high. All right, so to recap what I just showed you, you can control the logging verbosity with a feature flag. You can set up an alarm to trigger that feature flag, and then you can automate the flipping of that feature flag. Okay, key takeaways. We're almost done here. So there are 3 of them. Number 1, I just covered it a little bit. Resiliency is more important than other features. It is a mindset change for a lot of companies. But Moyes talked about how important resiliency is for Fannie Mae. Every second that Fannie Mae is out is, I don't know the number, and he's probably not going to tell me, but it's probably millions and millions of dollars that can be impacted. So resiliency has got to be the feature that you focus on. Number 2, build for resiliency. I love that Werner quote, which says, everything fails all the time. You should be ready that some core piece of your infrastructure is going to go down. You should limit the number of dependencies you have, and you should find some sort of a fallback where possible. And the last one is start small and then build on that. Different people are at different parts of their journey. I talked to the people in the crowd a little bit. There are some people that are looking just to get to that very, getting from 5 nines to 7 nines. There are some people that are just looking to get started on their resiliency journey. So start small. We gave you some cheat codes, and again, you'll be able to watch this video later on YouTube, and we'll also be here for questions. But figure out what's going to work for your organization, adapt accordingly, and then build on top of those successes. Okay, in the Venetian, there are kiosks in the middle in the AWS Village. Highly recommend that you go there, and there's swag. But you can also get demos of some of this stuff, and you can get some literature and those kind of things that you might want to do. We'll be there for some of the time, but there'll be other experts from AWS that can help you and answer more in-depth personal questions. And if you guys don't mind coming on stage, this is it, what we're going to do. I really appreciate you all sticking around. I know it's late and there's happy hours going on and it's Las Vegas, so you probably want to get out soon. We're going to be on the side of the stage over here to answer questions. Again, come to the booth and the kiosks in the middle of the Venetian Expo Hall. But thank you very much for your time.
Thank you.